Alright, hey everyone, welcome back to CSEC Add Maths Made Simple. Today we're going to be talking about differentiation. We're going to be learning how to differentiate using the power rule, the chain rule, the product rule, and the quotient rule. We'll look at simple examples you'll see in Add Maths step by step. Alright, and the first rule we have to talk about is the power rule. The power rule is the easiest rule. The power rule says that if y is equal to x the power of n, then dy dx is equal to n times x and minus 1. And let's do an example right now, okay? So let's say we're given y is equal to x to the power of 4, then dy dx is equal to 4x to the power of 3. Alright? It's as easy as that. So as you can see, we multiplied n. This will be n. This would be n. No. You put n at front and you minus n by 1. So it would literally just be 4x to the power of 3. Let's do one more example. Just so I know you understand. Alright, so given y is equal to 3x to the power of 5th minus 2x cubed plus 4. Okay, so dy, which is y with respect to x. This means y with respect to x. So dy dx is equal to, alright, first of all, the derivative of any constant is 0. So this is just equal to 0. 4 is equal to 0, right? So just cross over that on your paper. Okay? So 5 times 3, that is 15. 5 times 1, that is 4. So 15x to the power of 4. Okay? And 3 times minus 2, that is minus 6. I mean 3 minus 2. 3 minus 1. My bad. That is x to the power of 2. So it will be x minus 6x squared. Alright. Pretty simple. Just multiply by the power and reduce it by 1. Okay? And now we're going to be going towards the chain rule. Alright, the chain rule is used when one function is inside another. Okay? For example, y is equal to 2x plus 3 to the power of 4. Okay? This would literally be 2x plus 3 times 2x plus 3 over like 4 times. Like, who really has time to differentiate all of this? Like that, you know? So they invented something called a chain rule where you can just take the derivative of, well, the outside bracket and take the derivative of the inside bracket. And then you could multiply them by each other to get the derivative of a function inside of a function, okay? So first of all, the outer derivative that would be, all right, so just take dy dx of the outer derivative. That would be u to the power of 4. So derivative of that would be 4u to the power of 3, right? And u is equal to 2x plus 3. So that would be, the outer derivative would be 2x plus 3 to the power of 3, okay? Now we have to, bro. Okay, so to get the inner derivative, we would go inside the bracket. What's the derivative of this? Okay? What's the derivative of this? Derivative of constant is 0, so this is 0. So this is just 2x to the power of 1. So 2x 0 is literally just 1. Wait, no. Yeah, 1. No. X to the power of 0 is 1. So just be 2 times 1. 2 times 1 is equal to 2. So the inner derivative. Alright, so what you want to do now is multiply the outer derivative by the inner derivative. So it would literally just be 2x plus 3 cubed times 2 equal 8. 2x plus 3 cubed. Alright. That would pretty much be it to this question. So dy dx, which is y with respect to x equal to 8, 2x plus 3 cubed. Yep. Always differentiate from the outside in. And for the next example, we'll be differentiating a trigonometric function. I know that many people have issues with this, so I'll try to make it as easy as possible. The first thing you want to do is differentiate the outer derivative, because we're using the chain rule. So outer derivative would just be cos 5x, cos. And the inner derivative, we just derive this, right? So inner derivative would just be 5. So we are going to multiply the outer derivative by the inner derivative. So therefore, dy dx equal to 5 cos 5x. Wasn't that easy? All you do is multiply the outer derivative by the inner derivative. Okay, and now we're gonna cover the product rule. Okay? Basically, when two functions are multiplied by each other, we have to use the product rule. So if y is equal to u times v, then y with respect to x is equal to u prime v plus u v prime. Alright, so let's do an example. Given y is equal to x plus 1, x squared plus 2x, let x plus 1 equal u and x squared plus 2x is equal to v. Okay, that means du dx is equal to 1, and then dv dx is equal to 2x plus 2. Also, u with respect to x is same thing as u prime, and v with respect to x is same thing as v prime. Okay, so now we can solve. It's kind of look very similar. I'm sorry if that confused anyone. Anyway, so we would just do u prime times v is just 1 x squared times x squared plus 2x plus u times v prime, which is x plus 1, 2x plus 2. You can simplify, but just know the answer would be x squared plus 2x plus x plus 1, 2x plus 2. You can simplify if you want. I don't think it matters much. Actually, if you're in an exam, try to simplify as much as possible. Okay. Alright, so let's do the same for another question. Let's do one involving a trigonometric function. So let's say x squared is u and v is equal to sine x. That means u prime is equal to 2x and v prime is equal to cos x. That means dy dx is simply u prime v plus v prime u. So what is u prime? 2x. So that would be 2x. What is v? Sine bracket x plus what is v prime? cos x times u, which is x squared. So it would be 2x sine x plus x squared cos x. And then you could just simplify if you need to simplify. Alright, so the next thing we'll be covering is the quotient rule. We use the quotient rule when we are dividing one function against another, right? So let's say if y equal uv, u divided by v, then dy dx is equal to v u prime minus u v prime divided by v squared, where u is a numerator and v is a denominator. Let's do an example. Given y is equal to x squared plus 1, let u equal x squared plus 1 and v is equal to x. That means u prime is equal to 2x. V prime is equal to 1. That means, let's use the by formula. What is v? X. Yeah, v is just x. And multiply that by 2x. Minus u, what is u? X squared plus 1 multiplied by v prime, which is 1. Divided by v squared, which is x squared. So that would be 2x squared minus x squared plus 1 over x. Well, I have to scroll down. Divided by x squared. Alright, let's do one more example of a quotient rule. This time it'll be a trigonometric function. Y equals sine x divided by x squared. Now let's say let u equal sine x and then v equal x squared. So as we know, dy y with respect to x, the quotient rule would just be u v prime minus u prime v divided by v squared. Okay, so let's find u prime. U prime is equal to cos x. V prime is equal to 2x. Alright, so now let's plug these into our quotient rule formula. So u is equal to sine x. So sine x wait, did I just make a mistake? No, I did not. Sine x 2x minus u prime. What is u prime? Cos multiplied by x squared divided by x to the 4th power. So our answer would just be y with respect to x equals 2x sine x. Wait a minute. Did I do something wrong? I don't believe I did anything wrong. Okay. It would just be 2x sine x minus cosine x no, minus x squared cosine x divided by x to the power of 4. Alright, so remember the pattern: bottom times derivative of top minus top times derivative of bottom all over bottom squared. That's the quotient rule. Yeah, and I really hope that this video helped you. So let me just give you a summary of everything because we kind of did a lot. So power rule. So okay, in calculus you have, well, in admaths, introductory calculus, you have a couple of rules: the power rule, the chain rule, product rule, and quotient rule. These can help you find the derivative of functions. And yeah, so for the power rule, this is a formula. Yep, it's no n minus 1, put n at the front, so that's 4x cubed. Chain rule, just get derivative of the outer function and inner function and multiply them by each other. Quotient rule, you just have to memorize this formula pretty much. And then for the product rule, the formula for the product rule would just be dy dx is equal to v u prime plus u v prime. Hope that would be it. So if you remember this, I think you should be okay for this part of your exam. I hope you learned something from watching this video.